peeps, it's Sophie here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're dealing with the 2018 grade 12 physical science paper, and this is a question on work energy. Okay, it says the diagram below, which is not drawn to scale, shows a vehicle with a mass of 1,500 kilograms starting from rest at point A at the bottom of a rough incline, so that means there's friction. Point B is 200 meters vertically above the horizontal. Okay, so it says the total work done by the force F that moves the vehicle from point A to point B in 90 seconds is 4.8 times 10 to the 6 joules. Now that means basically a force of some engine or whatever it is that is driving the vehicle. Okay, so let's get started. So 5.1 says define the term non-conservative force, and that is in the blue sticky note there. It says a force is non-conservative if the work it does on an object moving between 2 points is dependent on the path taken. Okay, and then following on from that, 5.2 says is the force F, which is that, like I said, that engine force or the driving force, a conservative force, yes or no? And the answer is actually no, because if you look at it, there's an incline here, which means that if it weren't inclined, the force would be completely different. So that is a non-conservative force actually, because it is dependent on that path taken. Okay, so 5.3 says calculate the average power generated by force F, and we know that average power is the total work done by that force over the change in time, and that's been given to us right here in the question, so that's pretty straightforward. Then we say power is equal to the work, which is 4.8 times 10 to the 6 over change in time, which they've given us to be 90 seconds, and that gives us 5.33 times 10 to the 4 watts is the unit of power. Okay, cool. Then it says the speed of the vehicle when it reaches point B is 25 meters per second. Okay, then it says state the work energy theorem in words, which is shown in the yellow sticky notes, and it says the net work done on an object is equal to the change in the object's kinetic energy. So we can use that in question 5.5, which says use energy principles to calculate the total work done on the vehicle by the frictional forces. Okay, so following on from that definition question, it says that the net work is also equal to the change in kinetic energy. So what we can do is we can split up the work components and make them equal to the change in kinetic energy, the total kinetic energy. And we know that if we draw a little free body diagram in the corner here, that we have a force F, which is by the engine. We've got a frictional force, which is down the slope. And then we've got a weight force, which is going vertically downwards. So if we split up the work for each of those components, then we get the following. So if we start with the net work is equal to the change in kinetic energy. And then we split those up. So that's the work of weight plus the work of friction plus the work of force F. And that's equal to the change in kinetic energy, which is a half m. And then we can split that into the square of the final velocity minus the square of the initial velocity. Okay, so that is the change in kinetic energy there. So now we can deal with the final and initial parts of this whole thing. And we're going to assume that the upslope component, or all up components, are positive. Okay, so we're just going to assume upslope components are positive. So let's start with the weight. So we've got mg of the weight force. We know that that is the force of weight, and then we need the distance it travels, which is the perpendicular distance to the ground, because the weight is acting downwards, so that's in the direction of the force. And if we go final distance minus initial distance, we know that that is 200 minus 0. But we know that the weight is acting downwards, which means it's doing work downwards, which means that that is a negative force. Okay, well, that's a negative work. Okay, then we don't know the work of friction. But we do know the work of force F, and that's just 4.8 times 10 to the 6. And that is equal to the term, the kinetic energy term, which is a half 1,500, which is the mass of the vehicle. And then the final velocity, which we know is 25 meters squared, and the initial velocity, we're going to assume is 0 because it starts from rest. Okay. So, and yeah, so it's only the weight force that's the negative one, because the rest are kind of, well, we kind of expect the work force to come out negative, because we know that the vehicle is traveling positively up the slope, which means friction is going to oppose that. But we don't know that yet, so we're not going to assume it. But when we sub everything into our calculator and solve for the frictional force, that gives us minus 1391,250 joules. And can you see this force is negative here, which means that it's opposite to our positively assumed direction, which means it's down the slope. Okay, so that would be the work done on the vehicle by the frictional forces. You can convert it to scientific notation if you want as well. Okay, so that's it for this question. But before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. You can read all about them in the description below. Also, be sure to visit our website for more of these epic tutorial videos. And if you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. But until the next time, stay epic.